Can hear you, sir.
Sorry, I didn't know I was muted. Sorry. All right. Good morning, everyone. My name is Samuel. My name is Samuel Ekele, and I'm a DevOps and infrastructure engineer. And today I'll be speaking on this topic: how Docker and Kubernetes. In these presentations, we're going to learn what Docker is all about. We're going to look at Kubernetes. We're going to look at how to integrate these two tools, Kubernetes and Docker, and we're going to look at how to deploy your containerized applications with Kubernetes and how to manage your containerized applications with Kubernetes. And there's also the question and answer sections where I have some questions for you, and then you also can ask the questions for further clarification. Right. So, what is a Docker? So, these two tools, Docker and Kubernetes, actually are two essential tools in the modern application deployment used by DevOps engineers or app deployers, right? Depends on which title you find yourself or designation, really. Docker is a containerized application in the sense that Docker encapsulates your codes, everything your applications need to run, right? To which include your code, runtimes, and settings and every other things, everything that your code needs to run. Docker package them into a container and make it portable to run in a separate environment, right? And when you have this kind of process where you have to package all your applications and then have so many of them, managing so many of these containers become a little bit complex. That's when Kubernetes now comes in to help you manage the containerized applications, right? So in these presentations, we're going to look at how Docker works with Kubernetes to provide a robust environment for deploying and managing applications. So what is Docker? Docker is an open source platform which automates the deployment and scaling and managing of your application inside a container. When we say container, what do we mean? Container is a lightweight, is a lightweight executable unit of a software. Basically, what Docker helps you do is to encapsulate your applications, your application runtime, system tools, library settings, and codes into executable units, right? So that it can run in any environment it finds itself without depending on the environment itself, right? So before Docker, we have these issues with software development process where the developers develop an applications, it works in his laptops, and when another person runs it in a different environment, it fails, right? Docker comes in to solve this problem so that instead of having your applications to run in different environments, you have your application package with everything he needs to run, so that any environment they find itself, it will be able to run. That's the problem Docker comes to solve. So looking at Docker, this is Docker logo. This is the logo of Docker, right? So in this case, Docker is more like a portable virtual machine, but the difference is Docker will allow you to run different applications, so many other applications on a single virtual machine. And each of these containers are actually running in isolation, right? As you can see in this ship, let's say this is a ship, right? and it has so many containers in it. That's exactly how Docker works. Docker carries so many containers. It can run so many containers, like hundreds to hundreds of containers. And each of these containers is running a service in isolation. It is not affecting the other one. Is not sharing its resources with the other, or this environment with the other one. Everything it needs to run is already packaged in that container and is running that container in isolation. So it makes it possible for you to run so many applications in one virtual machine. This wasn't possible before Docker, right? But now Docker has made that easier. And as you can see, if you have so many containers running different services and all that, making them to communicate with each other, managing each of these containers become a bit complex, right? That's when Kubernetes comes in. There are key components you need to understand with Docker. The first one is Docker engine. Docker engine is the runtime that builds and runs your Docker container. So that thing that helps you package your applications into executable unit of software is the Docker engine that makes that possible, right? And then we have Docker image. Docker image is the lightweight standalone executable package that executes everything. So when you package that your applications into container, into lightweight, right? That executable unit that you can send anywhere, you can put anywhere for somebody to reuse is what Docker image is, right? And then you have Docker Hub. Docker Hub is like your Git repositories where you put your code, you manage your code, you save your code, right? You store your code, basically. Docker Hubs is almost the same thing, where you package your applications and you put it in a repository. Repository this time is no longer your code, it's no longer your software code, source code, really, but now it's your Docker image. So you push your Docker image there. Wherever you want to use your Docker image, you pull it from there. And if someone else wants to use your Docker image, as long as they have the names and then the tags, you just pull it and use it. This way, you don't really need to have access to the source code and every other things. You already have everything about that application packaged into that image for you. So you pull it and use. Then Docker container. That image that you push to Docker Hub that somebody can pull is not already running. It's not running. Nobody can access it, right? You only have the package software. To make it run, you need to create an instance of it, right? So that anybody can, it becomes your application, a running application. That's what the container is. So container is the running instance of that image that you push to, that you build or you push to Docker Hub or something like that, right? So this key component, you must remember it if you want to understand Docker, right? Docker engine, Docker image, Docker hubs, and Docker containers. There are some other ones, but these are just the key components that you need to get yourself familiar with to play around with Docker. And what is Kubernetes? And Kubernetes, on the other hand, will help you manage, orchestrate the containers that we just seen, right? So Kubernetes is an open source container orchestration platform that automates the deployment and operations of applications container across clusters of hosts. It provides a platform for automating deployment, scaling, operations of applications container across clusters of hosts. So when you have so many containers to manage, it becomes a bit complex. Managing their network, managing their services, managing their integrations and every other things and scaling them also become a bit complex. This is a problem that Kubernetes come to solve. So Kubernetes help you to manage your applications. Most of the modern applications are before the start of the presentation, I mentioned that most of the modern application deployment use these tools. Reason because it auto scale, it helps you to auto scale, right? Let's say the likes of Facebook, most of these modern applications you use today that you barely hear their downtime or running out of resources and all that is because it's running in a Kubernetes environment, right? Kubernetes is either auto scaling up or auto scaling down, right? So you don't need to worry about whether your application is going to die or the application is going to run out of resource or something, because Kubernetes is going to help you manage resources according to your request. So if there's huge request to the application, it will scale up, and if it goes down, it will scale down and all that. So that's one of the importance of Kubernetes. And Kubernetes also have its own key components that you need to understand before you can play around with, right? So the first one is Node. Node is like your physical or virtual machine that runs a container, right? Like we saw the container with Docker, the container runs in an environment, either virtual machines or your physical machines, right? So Kubernetes provides you with a node. That's your node that runs that container inside Kubernetes. And a pod is the smallest deployable unit in Kubernetes, consisting of one or more containers. So the smallest deployable unit that has maybe 2-3 containers is what pods is in Kubernetes. And then we have the replica sets ensure a specified number of pod replicas are running. So when deploying a Kubernetes, deploying your applications with Kubernetes, you will have to like do something like your applications to auto scale, right? You want it to auto scale, scaling your containers to maybe 2-3, right? When there is a surge, traffic surge or something like that, you want it to scale up. It's going to replicate that containers multiple times in order to accommodate the request, right? So that's what a replica set will help you do. And then we have deployment to manage the deployment and scaling of replica set. So that replica set that is auto scaling itself, scaling up, replicating the containers and then going up and down is managed by a deployment. So the other one is service. Service is a stable endpoint for accessing a set of pods. Service manages the communications between each pods, right? And we have the config map and secret. Config map and secret helps you to manage configuration settings and sensitive data, right? So that's what a Kubernetes is all about. Now we understand that Docker helps to containerize your applications and Kubernetes help you to orchestrate, manage, and automate the deployment of that container, right? At scale. That's the two different things these two tools does, right? I explaining this is beyond the purview of this presentation, but this is just the architecture of Kubernetes, right? We have the cluster management, which manage your nodes. Your node, you have the worker node and the sorry, can you still hear me?
Yes, I can hear you, sir.
All right, thank you very much. So Kubernetes has your networking sections where your service lies, ingress, network policies, and every other thing is configured, managing the networking of your services, your containers, and all that runs in that cluster. And then you have the storage that actually stores your data, persists your data and in different classes and all that. So It manages the storage of volumes. We call it volumes, right? The data storage, basically we call it volumes in when using Kubernetes or Docker. So we have the configurations that manage your secret config maps and all that. You manage your environmental variables, your sensitive data and all that. So deployment managers also help you manage all these deployments, stateful set, and every other things within the clusters and all that. So this is the secrets where you manage assets. You configure your network policies, who have access to what, which service have access to which service and all that. This is where you configure them. So monitoring and logging. Monitoring and logging, you monitor the performance of your application in a cluster and all that. So this is just the architecture of how Kubernetes work. Then integration of Docker and Kubernetes. How Docker and Kubernetes work together. Kubernetes by default use Docker container at runtime as use Docker container runtime as default, right? So why Docker handles the containerization of your application, handling the packaging of your application into portable, executable units. Docker handles the orchestrations, the managing, deploying, scaling, and running of that executable unit of software, right? So Kubernetes manages the life cycles of that applications that is packaged, that is running in container, basically. So this is how it's integrated. And we're going to look at the key benefits of using Docker with Kubernetes. Number one is scalability. As I've mentioned with replica sets, your applications will automatically scale up or down whenever depends on or based on demand, right? If the demand is high, scale up. If the demand is down, it scale down. That's the reason why you barely have issues with most of these modern applications, trying to access them and resource usage issues and all that. So if you wake up in the middle of the night to access Facebook, you're still going to get the same response and all that. So it's scaling up and down based on demand. Even if the whole world is trying to access Facebook at the time, it will accommodate it because Kubernetes is there on the back end that is actually auto-scaling it up when this request comes and then scale down when this request comes down. So you don't really have to do anything. It's automating this process for you. Then we have resilience. Resilience automatically restart failed containers and reschedule them on different nodes if necessary. So if you are not using Kubernetes and your containers, something happens to your containers in your virtual machine, for instance, it means that you're going to have outage in your of your service, right? But Kubernetes will help you recreate same containers, right? Check the health of the containers. If the container is not doing well, the container is not healthy, it will kill it and create a fresh one, right? Or it can heal the container for any issue the container is having and all that. So that is handled by Kubernetes. And portability. Mentions that you package your application into executable unit. It means that it can run in any environment easily. So instead of pushing all your code, pushing the dependencies and every other thing across multiple environments or multiple environments or server virtual machines or the likes, the only thing you need this time is just your image. If you run your image, you have your application. So it's portable. You can distribute your application easily, right? And then resource management. Kubernetes will help you manage your resource efficiently. More like that scalability, elasticity. Yes, the elastic nature of Kubernetes will help you manage your resources efficiently, because you are not going to provision more than you require. It's just giving you resources based on what you need. So it depends on the request that is coming to application that is going to make a resource available for. So it's going to accommodate. And then when this thing is not coming, if the demands or the requests are not coming that huge, you scale down and then manage your resources for you. That means you are just paying for only things that you use. So creating a Docker image is simple, right? So when you build your applications, you write your code. Your code has a directories where you put your code and all that, right? And then in that code directory, all you need to do is just to create one file called Docker file. So in that Docker file that you are going to define everything that you want in that container, right? And this is how it looks like. You have the base image. The base image, this is basically for a Node applications or JavaScript application, right? You want a base image from Node version. Node this is a base image, right? And then your work directory inside that container is the application. This is the application. And you want all the code in that directory, to be copied into your working directory. Basically, that's the command, right? So in this case, you already have your code in your root directory, in a directory where you are creating your Docker file. So you copy this command like this. You can actually select which scripts or which directory or which folder you want to copy into it. So you can define them here instead of doing it. But doing this shows that you want to copy everything. Anything that it sees in that directory, you should copy it into your application. Basically, that's what you do here, right? Then you run npm store to install the package managers for the Node applications. Remember, these Node applications, if you are doing for Python script, it's different thing, right? If you are doing for Java applications and all that, this is not what you do, right? They have different commands for installing their package managers and all that. So you expose port by default, Node runs on this port, right? And that is it. When you do this one, you run docker build -t, you call your image a name. You call it any name you give it, right? Your image a name, and then latest, and then you put dots here. This dot here means that the Docker file is actually in the same directories where you are running this command. Meanwhile, before running this command, you must have your Docker running in the server or your computer where you are running this command, because it's Docker engine that is going to execute and build this your image for you, right? So this is how simple it is to Dockerize your application. So when you do this, you have Dockerized your application. If you want to check the image that you built, why is running is actually running with a logs. You are seeing the process of each of these things happening. So after building your application, it will give you a notification that your image has been built successfully, and you can check your image by doing Docker images, right? And then you see your image there. So the image name, you can use it to run your application inside same environment, inside same server, or you can push it to Docker Hub, right? when you push it to Docker Hub, it means that anybody anywhere in the world can pull it from that place, because you know it's not going to be easy to pull from your laptop or your virtual machines, right, to another. But when you put it to your Docker Hub, anybody can pull it from there and reuse it. So anybody that pull it from there, that spin the container, automatically have exact copy of your applications there. Hope we are following. Then we come to Kubernetes. Kubernetes, on the other hand, will help you, that containerized application, containerized application, Kubernetes will help you to continue the management of that application. So basically what you need to do is to create your YAML file, deployment YAML file. So the deployment YAML file that is created in the root directories of your application as well have this definition. App versions, you know, kind deployment, what are the metadata, you can put your information spec, replicas, you want 3 replicas, maximums of 3 replicas, right? So select and all those ones, match labels, all those metadatas, you put your all those metadatas, and then container, the names of the containers. Remember that our image we viewed the other times, we call it what? We call it my app latest. We call it my app latest here, right? So the image, you pull the image, this is where the Kubernetes will now pick the image by the names and tags, right? So you define it here, and then the running instance of that image is going to be my app. You can call it any name, right? You can call it any name, but the running instance, which is the container, is going to be my apps, and then the image name is this. So this container is going to run from this image, basically. So after doing this, you do kubectl apply -f deployment of YAML, and your application is live running in Kubernetes. This is how simple and easy it is. Do we have any question?
Just to confirm, you are not alone. Thank you very much, Samuel. That was wonderful. I don't have any question.
All right, you're welcome. Is container, Docker and Kubernetes clear to us, like how they function? Is it clear to us now?
I actually have a question. Okay,
all right.
So thank you very much for the very wonderful presentation. My question is now about both, which is, why is it that Docker is more advised to be used for local testing? Okay, let's say, for instance, before you start running your projects on the server, it's advisable that you actually have Docker installed in your system to mimic what you have in the server. Then you can test it locally before testing on the server. So if Kubernetes has these wonderful features, why can't we use it locally to test?
Of course, you can use it locally. You can use it locally to test, right? But remember that Kubernetes is not meant to just manage single. When you are managing only a single container and you are using Kubernetes, that is over engineering. It looks like overkill, right? Kubernetes' main purpose is to manage manage numbers of containers. So in your case for testing, of course, so many applications runs only on container, right? So you don't need to use Kubernetes when you are not managing complex or huge numbers of containers, basically. That's why you are using content. Your application is just one application, right? And then your machine. Reason why you are testing your local with Kubernetes with your containers is basically because if you don't want the application to run, all you need to do is just to kill the container, right? You remove the container and then your application naturally dies and everything clean up. So you don't really need to have any debris left. Like installing this on your laptop, installing this, installing so many things. You have to install so many things to make some Node applications to run or Java applications to run, right? But this one is happening in container. So if you just kill the container, all those dependencies, installations, and every other rubbish and all that will naturally go, right? And then you can create another one in second again. Basically, that's why you need to test in your environment, because the container is already providing you a mini computer, right, that makes the application work. That's basically what container instance also looks like.
Oh, wonderful. Thank you very much.
All right.
So please do we still have questions?
I have questions.
Okay.
So as you can see on my screen, number one, what is the primary functions of Docker in a DevOps environment? What does Docker do? Number one, A, orchestrating containers. B, packaging application into containers. C, providing cloud storage. D, managing Kubernetes cluster.
B.
Kolawole. That's correct.
Yeah.
Okay. What is the main benefit of using Docker with Kubernetes? Simplify manual deployment process, increase cost of infrastructure, enhance scalability and resilience, reduce security measures.
Enhanced scalability and resilience.
All right, that's correct. I think I should be coming from DevOps guy. Number three, in Kubernetes, what is the smallest deployable unit that can be created and managed? That was mentioned in our presentation more than 2-3 times. In Kubernetes, what is the smallest deployable unit that can be created and managed? A, node. B, pod. C, cluster. D, service.
Pod.
You said what?
Is it pod? Pod.
Yes.
Yes,
Pod
yes,
is correct. Pod is correct. So Docker and Kubernetes, in conclusion, Docker and Kubernetes together provide a powerful and flexible platform for deploying and managing containerized applications. Docker handles the packaging of application into containers, while Kubernetes automates the orchestration, scaling, management of these containers. This integration allows for highly scalable, resilient, portable application, making it a cornerstone for modern software development practice. Thank you very much for listening.
Thank you.
I hope there's no other questions, right?
Yes, it's not a question from me.
Okay.
Okay, thank you, everyone. Thank you so much, Mr. Samuel. That was really, really insightful and very, very, it was very awesome. Thank you, everyone, for joining. Please, let's take note of our days. I've tried to bring the schedule forward so that we can be reminded of our days. You can just make your topic available. Okay, and a very important announcement before we drop off the call. Please, those of us scheduled for Friday, our presentation will have to be postponed because Friday, Ekele will be making an important announcement via the KD channel. So everyone is advised to be available. So those of us for Friday, I think it's David, I would have to reschedule your presentation. Sorry for any inconveniences it may cause. Please do have a productive day. Thank you, everyone.
All right. Thank you.
Thank you.